issue. Okay? This number right here, this 980 out of the 1708. What is that? Someone have a calculator?
Yeah.
Do that for me real quick. All right. All right. So based on our survey, 57.4% of the people surveyed actually think that global warming is a pressing issue. Okay? This, again, this is data that we collected. This is data that has been collected. This is describing something about the people that were surveyed. This is telling me the percentage of people that think that this is an important issue. This number is what is called a statistic. Now, in this class, the word statistic is used so much that it's oftentimes easy to confuse what makes it a statistic. Okay? In the context of gathering data, a statistic is a value that describes a sample. In this case, it's a numerical value. This numerical value of 57.4% is describing the 1,708 people that were actually surveyed. Okay. All right. So statistics, in this case, can describe samples. Well, on the other side of the coin, we also have what are called parameters. A parameter is a value, much like a statistic, except it describes the entire population. Okay? So a parameter is a value that describes a population. Oftentimes in statistics, what we're trying to do is we're trying to use this statistic, we're trying to use the sample data that we collect and use this statistic to make a good guess about what the parameter is. That's our goal. We take data from our small samples, we get our statistic, use that now to make a guess about what the population relation is. Now, do you think that 57.4% of all U.S. adults believe that global warming is a pressing issue?
No.
Do you think this exact number is going to describe the entire U.S. population?
No.
Probably not. Is it close? Do you think it may be a close?
Could be depending on where they're asking. Yeah, it depends on the region.
There's a lot of little subtleties that we have to, that we'll ultimately be worried about. But for now, let's assume that everything is in a perfect world, the data is perfect, and there's no tainting of anything, and that we ask the correct people this question. Is it necessarily going to be the case that this 57.4 is also the parameter? No, it's very unlikely. Very unlikely that this number is going to also describe the percentage of U.S. adults that do truly believe global warming is a pressing issue. Now, provided we collected data well, this number should be reasonably close, but it's not going to be exact. Okay? In fact, almost never will the sample statistic value be the same as the parameter. For example, if I was to look in this room, and let me double check my numbers here, there are 8 females in this room. There are 17 males. Okay? If one was to treat this room as a sample of the population of Southwestern College, what would be the ratio of men to women based on the sample in this class?
2 to 1.
8 girls,
About 2 to
17
1.
guys, about 2 to 1. Okay? So 66%, 33%. Now, do you believe that 66% of all Southwestern College is males? No? Okay. In fact, I think the actual numbers are something like 54% male, 46% female. So, small sample here. Again, small sample, 25 out of 600 and whatever number of students. Okay. we got a result that was pretty different. 66% versus 54%. We're off by, a reasonable amount. But, it wasn't like 90%, 10%. So it's close, but not exact. In working with statistics, this kind of thing happens all the time. It's not going to be the case that your sample statistic value is going to always be near the target value. And that's, something that you have to deal with. That's inevitable whenever you go out and collect data from samples. You're going to get some variability amongst your samples. If I was to go out and ask another 1,708 US adults if they thought global warming is a pressing issue, do you think I would get 57.4% again?
No.
Probably not. In fact, it's highly unlikely. Okay? And that's natural. That happens. That happens in statistics all the time. You're not going to get the same results every time you do the same experiment or observation. Okay? That's natural, and that happens. And statistics has come up with ways of dealing with that. And we'll learn some of those as we progress through the course. But when you see the word statistics and when you see the word parameter, just remember those are things that describe particular groups. Okay? Statistics go with samples. As a convenient way of remembering that, they both start with S. Parameters and population, same thing. They both start with B. So, have an idea of some statistics and parameters. Let's look at a couple more examples of identifying key aspects of interest. All right, so the first example we'll do here, we have 1,400 MBA students, MBA grads, 2009. Surveyed found average salary of $69,000. All right. A couple questions to ask. First question: what is the population? Okay. In this case, this particular question is asking about MBA grads. Okay? So our population in this case would be MBA graduates. Now, did we take a sample of those or did we take all of them?
Probably all of them.
I'll tell you that last year Southwestern College graduated 60 MBA students. There are a little over 2,000 MBA programs in the United States. Do you think that we surveyed all of them or just a sample? Sample. Okay. So in this case, we took a sample, and the sample we took was the 1,400 surveyed. Okay. We collected some data from these people, and what we found was that their average starting salary was $69,000. What is that $69,000? That's $69,000. That $69,000 is in fact a statistic of our survey. All right. Not too bad. Let's look at a similar question, or a similar example. Some subtle differences. The average starting salary of the 62 SC MBA grads